Hey there guys, welcome to the next chapter of ours, and in this one we're gonna do something called distance-based blending, or at least I think that's what it's called, because I mean there is like no official nomenclature about that stuff. So yeah, anyway, just roll with it. So what we're gonna do now is we're gonna create a material that is sort of gonna help you alleviate those horrible tiling, visible tiling artifacts that video game artists has been getting since forever. And yeah, and we'll also do something very nice, which is we'll get acquainted with material functions and their use so that you can build your materials way more modularly. So yeah, here you see my content browser, and what I'm going to do now is I'm going to create a new material function. And let me just drag this window over. We don't need it in meshes. Let's go into the materials dot functions, and just in case you didn't know, you can click functions here. You can put a dot after a material name or a grouping name or whatever it's called, and just create an additional folder. That's sort of, well, you'll see just in a second. We'll just call it distance blending for now. And yeah, I hope you see what I was talking about. Here we have our materials, and we just have like a subfolder called functions, and there it is. There is our material functions, and let me just drag it over here, put it like nicely in the recording area. And what we're gonna do today is we're gonna build a material that well, for now, like something that we're going to do in here in this material function, we're basically going to build a function that gives us a grayscale mask that changes based on distance. So we can further use it in the linear interpolate, or with the linear interpolate node as an alpha. That's the whole idea. So yeah, the first thing, wait a sec, where's my material expressions? Yeah, there you go. So the first thing that we're going to do is we're going to grab a camera position, because how do you calculate the distance if you don't have your camera? And camera basically represents the player in the game world. And the other one that we need is a world position. A world position basically gives us a position of each pixel in the level, well, on screen basically. So yeah, now I just grab those two. There is a node called distance, which is pretty self-explanatory, I guess. It just calculates the distance between the 2 points in space. And after that, I mean, right now we can plug it in already. And you'll just see that it's very bright, and that's because it's not clamped. And it's kind of hard to, understand how it could be useful at this stage. But now we're going to grab a divide node. And yeah, basically you can grab the logic, right? That if the distance is like very small, then you get dark colors like black technically, and then it just gets higher and higher with the value. But the thing is that the world is pretty huge, and you obviously won't have always your camera and your pixel within 0 to 1 distance to each other in world coordinates. So what we're going to do now, we're going to actually take a divide, and I know that usually we just go with multiply and use like a small number, but we're going to divide it by a lot. So it's going to be a pain in the ass to calculate, so we'd rather go with divide. And now you see me dividing this, and by something pretty huge like 496 or 4096, and the moment I do that, you see that's it. Now something starts happening. The closer we get, it gets brighter, and the further we get, it gets whiter. And yeah, that's the thing, because now we made this sort of little gap that we have between 0 to 1 4096 times wider, and that works. But now we can probably toy with it a little more, add some more, well, if you would imagine it like a mask, there is this sort of a gradient that's going on, and you probably want to adjust, the contrast, the fall off. That's basically what the power node is usually for. And we're also going to create another constant and make it something like, I don't know, 2 for now. And yeah, a constant clamp, I guess, because we don't want to go, higher than 1 or anything for linear interpolate, because that's where we're going to be using it, because it might get funky from there. Oh, and yeah, you see the constant clamp immediately helped. Or maybe it was just the power node. Yeah, it was, well, whatever. But you see that now we get our mask, and we could probably get something darker when we're closer, because we want it to be like black right in front of us too. So we probably want to keep it as dark as possible for like few, like 10 meters or something close to us. We want this transition area to be further away, not just start immediately at where the camera is. So if we pump up the contrast, you see that up close we will get our initial value, and then going all the way to the back, we're starting getting white. And you know what? That's the function that you will use to calculate the distance. But there is one more thing. Since we're building this stuff as a material function, what we want to do now is actually create a material function input, whatever it's called. I think it's just input in here. Let me look. Yeah, function input. And here we just specify what kind of stuff do we input into our material function. So input name, we can just call it, I don't know, fall off for this guy. And it's not vector3, it's just a scalar value. And for preview, we can just plug this in, and then we plug this in, and technically that should suffice. And the same goes for our distance value, because basically when we're dividing it, we're creating this distance, transition distance that's going to be there. So we probably want to adjust that as well. So I'm just going to copy it. And you see it automatically changed the name, because you can't have two absolutely same inputs, but that's okay, because we're just going to call it distance. And once again, plug in the preview, plug it into the divide, and we should be done with our material function. So now the only thing left is to create the material itself and test it. Let me just apply it right now and get this baby out of sight. Okay, so right now I'm just going to go ahead and create an empty material, and yeah, I'm just going to delete the functions here, and I'm going to call it distance blending, and it should pop open at this point. Let me drag it over to the recording area for you guys. Okay, so resizing it, and then I'll just go into my content browser here and go into functions, and this is our only function, and then I'll just drag it over. And that's it. There you see you have your inputs that we put. Oh, and I think you're supposed to put an output in there. I don't remember if we did that. Yeah, output result is there by default. So yeah, it's totally okay. And I think that if you just Google it, well, search for it in the material function library, it should be there. I'm not sure. No, there's something that you can specify for it to appear, but we don't really care for that at this point. Yeah, so what we want to do now is we want to recreate the two constants that we had, the two parameters that we're going to use, because our fall off was 3. And oh, you know what? This is something cool that we can set up in here, I think. If we go into our, if we go into our input values here in the material functions, you can actually check this checkbox that says use preview value as default. Just do that, and it will allow you not to input anything for those guys. So that should be pretty comfy. And the other thing is, yeah, there's this box, the checkbox that says expose to library. Let's click that, and I don't know if it will be able to pick up immediately, but we'll see. Okay, so it's distance blending. Yeah, there you go. Now it actually appears here. So yeah, we just killed 2 stones with 1 bird. No, I'm kidding, I know it's the other way around. Yeah, so now you see that those inputs actually gone gray, and that means that we can not worry about actually plugging in something here unless we really want to, which is always nice. Okay, let me just widen the work area. And now I'm just gonna go ahead and grab a texture for us. Just give me a sec. Let's use something like this, a ground texture where the titling pattern would be pretty visible. And I'm just gonna use this one, no specular, normal for now, just because, well, the time constraints, just to save some time. So yeah, now I'll go and grab the coordinates, or coordinates, yeah. There we are. And now, you know, we might as well create a material instance this time, because I haven't been showing those to you guys too, because I mean, those are not exactly part of the whole logic behind the shaders that much, but it's actually quite handy to know. So what we'll do is we'll create, let's just use a constant free vector, convert it to a parameter, and set the first two RNG to be our tiling. So it's like X tiling 1, Y tiling 2. That should be good for now. And as the default numbers, let's just use 1 and 1. For now, that should suffice. And now what we're going to do is we're going to actually multiply our UVs, and then we'll just use a linear interpolate. I'll show you. Okay, we're going to have to sample the texture twice, which is not really good, well, for performance, but there's not much we can do about it if we want to actually use this stuff to sort of reach our goal here. But yeah, for presentation purposes, it's nice. You know, all's good. And actually, like later on, if you're actually producing a proper shader and you have a need in something that's not gonna, you know, what's gonna like, you know, fit your purpose. For example, if you're making something and you're probably thinking about using two textures, vertex blending, stuff like that, to sort of mask the tiling in the distance, you're still going to sample another texture. So it might be worth considering to sample the exact same texture. And you still sample it twice, but you don't store the other texture in memory, which is kind of good. And so, yeah, there might be quite a tangible trade-off here. So even though sampling something twice is not very nice, it's still better than well, a lot of other stuff. Let's just put it like that. So yeah, white was in the back in the distance. So this is going to be the distance, the value. And here's our alpha. And here's our diffuse. Well, let's just make it a plane. Okay, so now we can preview it right here, actually. Not a big problem. Or we could create a material instance just for preview purposes, which we're going to do now. So yeah, I'm going to just go ahead and close it. And then I'm going to my materials to find my distance blending. And I'm just going to right click the distance blending material and create a new material instance. So now I'll just click, I'll just push I'll place a dot here and go and write instances. So now we have a subfolder for instances. And there you have it. This is our instance editor, which I won't go in detail about, because this is not really the subject of our DVD. So you're right now, you know what I'm going to do? I'm going to go into our meshes and grab our desert mesh that we had, and it was pretty small, but let's just scale it, I don't know, 50 times, so it becomes pretty huge. Okay, let's make it 100. Yeah, so there you go. I just scaled it, and now I'm just gonna drag and drop our material instance from the editor, and there you go, and it's tiled just once, right? But now we can do something pretty neat. We can go ahead and make it a 5 or a 10 or a 15, for example. And now you see that it starts to tile and it becomes more visible. But hey, what do you know? Out there in the back, you see that this stuff obviously is tiled differently. So now you can actually have like pretty intense tiling up here, but not that intense tiling up there. And I mean, and yeah, I know that this particular mesh doesn't really lend itself well to, you know, describe this concept, but let's imagine you're having something a bit more steep, for example. Yeah. We see everything, more or less. So now it should be more obvious. And you know what we could do actually to make it even more obvious? We can go back to editing our original material, which I'm gonna go and do just now. And we can use the remaining points that we have here in our parameter to actually control the distance blend-in function. So let's just plug the blue channel into the distance and the alpha into the fall off. So now for defaults, we had this as a 4096 and this was 3 for fall off. And let's just specify it here. X, Y. Oh well, yeah, we could probably replace it with R, G, and B because it's kind of confusing. R, G, B is distance. We'll just call it distance. And for alpha, let's just call it fall off because hopefully we'll know what we're talking about here. And now let me just apply it and hide it out of sight for you guys. Okay, so here you see that we had our numbers already set up in the instance and we had it checked. So it didn't really go with the default. So now we're overriding, as you see here, our parent basically preferences. So we put 4096 and for here we put 3. And it should work, but it's not for some reason. Okay, let's try this one. Okay. Okay, so yeah, I have an idea about what's going on, and I actually think that you guys should know about it because this thing actually puts quite a big damper on the whole material function use if you're actually inputting a lot of, parameters of your own. So what you want to go and do now is grab a component mask. And I have no idea why, guys. I wish I did, but let's just make it an alpha. I usually do that and it works. You plug this in and you just plug this in through a mask. So now our alpha value is, going through a component mask. Because usually if you don't do that, then your alpha, instead of the alpha, even if you plug it in your material function, you get your X value, the red, which is kind of weird, or just something else totally unpredictable. So now I just got the, did another mask for the blue channel that we're using, and it worked. So technically, the compiler shouldn't pick this up as an additional instruction. I don't know, I haven't really checked. We can actually try it right now. It's 71 and 71, because technically if you're feeding the component mask a single channel, then it should just, skip through this operation altogether. So hopefully we're good in the optimization department, but it's still like in now, and you can see in the background we have tiling times 15. So let's make it 5. And in the foreground, let's just make it 1, or let's make it 15. So now we have up close, more tiling. So we want like a higher fidelity, higher textile density. And in the back, we can just lower it so it's not that visible. We can just divide it all by 3 and make it like 5 and 1, for example, just to give you a better idea. So the tiling is not that visible, but you see you have this sort of acceleration in here, and then out there in the back, it doesn't look like it's like super way more tiled. That's because it isn't. And I mean, if you actually go around, you'll notice that it just blends. You see how it slowly turns into something with less tiling. And this could really help you out with your terrains and stuff like that, because now you really don't have to do those complex, well, not that complex, but vertex painting setups, because you know what? Help yourself out. And you can actually blend just 2 completely different textures, for example, if you want. There is like an infinite number of uses for that stuff. But just as a general trick, I think that this is something very amazing to know. And yeah, thanks for sticking around, and I'll catch you guys on the next chapter that we're going to be doing. Cheers.